Hello everyone, this is Murat and today I am going to show you how to build a voting application, so decentralized application using Solidity, hardhat, ethers.js, React, and yeah. Right now I'm showing you the end result. In this tutorial at the beginning we are just going to write the smart contract, but when we finish the whole project it will look something like this. As you can see, it's quite basic in terms of design. What is it doing? Well, I can enter a title and description, and when I press add proposal it will propose something. As you can see, I have some dummy proposals here, and then I have some more readable, some more making sense making proposals, like, do you think blockchain will be the future? Description in the title. Let's say yes. When I say yes, since I'm changing the state of the blockchain, I have to pay for it. It's on goerli testnet. I know goerli is about to die, but I still have some test coins in it, so test money in it. So I'm just using goerli. You can use the new one. I think it was called Sepalia. We can check it. Oh, I clicked confirm. Now you see I have to wait a little bit because test networks are a little bit slow. And when it's complete, this should change. Oh yeah, vote added successfully. I think I didn't deal with the I think I didn't spend so much time on rendering logic, so it didn't render. But on page refresh, as you can see, we have a yes vote. So the idea is that the idea is that everyone can propose a topic, and everyone can vote on a topic once. So right now I wouldn't be able to vote again. It wouldn't work. I don't know if it's gonna show. I don't remember if it's going to show an error. Yep, you see, execution reverted because you have already voted for this proposal. So since I've already voted, I cannot vote again. So I can only vote once per proposal. So this is our application. I'm not creating a new one because I don't want to spend my very precious test ether. Anyway, let's get started. Now, for this project, we are going to use hardhat for writing the smart contract. Here I've created a voting dApp folder, and I have two folders inside, contract and front end. They are empty. I cd into the contract folder. Well, what do I need to do first is, just a moment, I need to initiate npm so that I will have a package.json file. Then, well, what I want to do is to install hardhat. Just a moment. npm install save dev hardhat. So we will wait a little bit for that. I think I'm gonna pause until it's done. So see you in a bit. Okay, all is good. Now I have to initiate hardhat by writing npx hardhat on the console, and I'm going to create a JavaScript project for this one. I will just say yes, and I think I'm going to pause again so that you don't have to wait for it. And we are back, we are rolling. So right now I have a hardhat project up and working. As you can see, when I open my VS Code, I use VS Code. I have a contracts folder, I have a test folder, we are going to write tests to, I have scripts, a deploy.js, etc. We are going to change all of these, we are going to write our smart contract. But before that, I want you to go and create an account. It's free, by the way, an account and an endpoint, an HTTP endpoint on QuickNote, because we are going to use this as a node provider. You can use many other node providers out there. You can use Alchemy, you can use Infra, etc. I'm going to use QuickNote. It's easy, it's really easy, it's rapid, and again, it's free up to one node, and you will see it's very basic. Just remember to create it for the network that you are going to use. I'm going to use goerli right now, but if you don't have goerli test money, I guess this yes, Sepolia test network. There is this Sepolia test network, so you can do it for that too, I guess. I'm pretty sure you should be able to do that. So just go, and if you want, you can pause the tutorial, pause the video, and go about and create a QuickNote account and endpoint. Also, for the tutorial, for the smart contract, I will need you to export your private key from MetaMask, which you will find, I guess, in account details. Yes, it says export private key. I'm not going to do that. Don't show this to anyone. It should be to your eyes only. So just you are gonna click that and you will get the private key. Again, don't show it to anyone. We are going to put these two values, the private key and the QuickNote HTTP URL in an .env file, so that we don't accidentally push it to GitHub. Now, okay, after this introduction, let's start writing our contract. I'm going to change the name of this. I could have deleted and created a new one. It's not important. Just a moment. Yes. And I want to change it like so, and I want to change it to MIT. So if you have never coded a Solidity smart contract, all smart contracts should start with SPDX license identifier. That's basically informs what is the license of this contract. MIT means it's kind of open source, so you can use this contract as you wish. And then we have to continue with a Pragma Solidity. This is the version of the Solidity compiler. This means that it should compile anything above the 0.8.0. Now I will have to, like, in order to write my contract, I will have to chill. I will have to start with contract keyword. This is how contracts in Solidity starts. And by the way, you see it's voting.sol. So now, just a moment, I want to close the close light, so I'm gonna pause just a second. I'm back. So as I mentioned, we are going to build a voting application, and before writing the code, I think it's better to have a clear understanding of what are we going to write, you know. So I wrote this contract myself, so this is a disclaimer that it might not be the best voting contract out there. It might not be gas optimized. It might have bugs and problems with it, so like keep that in mind. I wrote this by myself because I think that the best way to advance yourself is to try to create something by yourself instead of watching tutorials. Then why am I making a tutorial? In order to start doing something on a new language. I think it's better to start with some tutorials only after you get accustomed to the syntax and the logic of the language. It's time that you start writing your own stuff from scratch. Again, one more pause. Okay, today I'm pausing a lot. Anyway, so the things I need, that this contract should be able to add proposals. Also, I'm not going to start with a constructor. So as you can see, it started with a constructor method here. Constructor is a method that runs only once when the contract is first deployed. I don't see any use of it in this application, so I didn't use a constructor. You can use it, you can add something, whatever. We are not going to use a constructor. Well, our contract should add proposals. So like anyone who connected to the application should be able to add a proposal. The contract should be able to vote for proposals. So let's say I added a proposal. I said, do you like Eminem's music? And people should be able to vote on it. I should be able to vote on it, but I should be able to vote on it only once, because like if I could vote endlessly, infinitely, it wouldn't really mean anything. So we are going to take care of that. We should be able to get the proposal votes to see what is the yes or no ratio. We should be able to get the proposals so that we can see and vote on them, and in the UI later on we can show them. And also we are going to add a modifier to check if the proposal is valid or not. So you cannot propose, you cannot fire a proposal with an empty string, etc. Now let's start. So I started by creating the variables. So I mean, in this tutorial, I expect you to know a little bit Solidity, but if you don't, it's okay. I will try my best to explain. Also, I'm a JavaScript developer. Normally, like I transitioned from JavaScript to Solidity. So I will try to explain, I will explain things from the point of view of a JavaScript developer, and you will see what that means, because Solidity is a kind of different language than JavaScript. The syntax looks very similar, but there are some things that are weird if you are coming from JavaScript. Okay, let's start with a struct proposal. Oh, structs are like basically objects in JavaScript. You know, it's just you put some key value pairs. But the thing with Solidity, you cannot just, you know, in JavaScript you will say, let's say I'm going to create an ID. You will just say let or const or var ID. Well, in Solidity you cannot do that. You have, because it's a typed language. So if you are coming from TypeScript, it will make a lot of sense. You have to define the type of the variable. So we have a uint256 type of ID, which is a big. It will take a lot of bytes. So it can be a very long string of like data. I will have a string of name, like the proposal name, proposal ID, proposal name. So it's just a string. I will have a string of description. I will have again a uint 256 vote count, because I want to see how many, if I want, I mean, I haven't used it in my UI, but it might nice to see how many votes there have been, and it's very basic it, like if you want to get vote count, since we are going to have yes votes and no votes, it will be just an addition of the two, so it's all cool. UN 256, nope, yes votes and no votes. Also in Solidity you have to write this semicolon at the end. You know, in JavaScript it's not compulsory, in Solidity it is. If you don't, it won't compile. If you don't write it, it won't compile. Now I want to, you know, I need a way. I want to add a functionality to be able to know whether an address, a user, has voted for the proposal or not. So in Solidity there are these structures, data structures called mappings, and they are quite different from anything in JavaScript. You can check them out. I had some serious troubles understanding how they function. They are basically like something like objects and arrays all together in JavaScript. They are not iterable, so you cannot iterate on them like arrays. And actually, let's see. It should be Solidity by example, mapping. Yes. You see, it's a key value pairs. The key type can be any built-in value type, byte, string, or any contract. Value type can be any type, including another mapping or an array. I'm showing this because we are going to map something to a mapping. So because we can, and it's very, very useful. Normally, as far as I've seen, mappings are a great way to see what a particular address has been doing. Like you map values to addresses, so you can see, this address has this value, this address has done this, etc. Here we want to see, we are going to create a mapping, a private mapping. So in Solidity we have to define where the variable will be located in the memory. So I'm gonna say private because it's just I will need it. Has voted for proposal. Yes. So basically, like if I were to write this in JavaScript, it will be something like this. That's it. I'm not sure about this map, but this is the syntax. It's kind of confusing. It's still confusing for me, but you get the hang of it. Now what I want to do is I want to pass the ID. I want to map the ID of the proposal to a mapping of address to a boolean. What does it mean? Like I have an ID of the proposal which is of type UN256, and I want to see whether that particular proposal has been voted by a particular address and in what ways. So to do that, first I have to write the UN256. So why UN256? Because I'm going to use the ID of the proposal, and it's of type UN256. And another mapping, because again I have to know. I know it seems weird, even writing it seems weird, but again, to understand this, so I have this ID, and I grab the ID and I want to see, because with this mapping, you see there are two mappings. Mapping is a nested mapping. I want to query what, since there's this proposal ID and there are many addresses that voted for that proposal. So I grab the ID of the proposal. So I have the proposal, do you like the music of Eminem? I have to see with the use of this mapping, I want to see whether a particular address has voted for this for the proposal that is the proposal of this ID, so that I can use in the future in my logic whether this account, this address has voted or not, so that if it has voted for this particular proposal, it cannot vote again. So this is the idea, this is the whole idea why I need this, so that you cannot vote more than once to a proposal. Whew. Now it's well, I need to put these proposal structs somewhere so that I can reach them, and I'm going to put them in an array of type proposal. So wait, I mean, again, if you are coming from TypeScript, all of these make sense, but if you are coming from a loosely typed language like JavaScript, it's kind of confusing, because how do we create arrays in JavaScript? As you let's proposals equals bam, I have an array. In Solidity it doesn't work like that. In Solidity actually it directly works like that. First I have to define the type of the array. So my array will be of type proposal, so that only elements that are proposals can enter into this that array. Because you know, in JavaScript, in an array you can have, let's say let's my r. So you know, I have this array, I have 1 number, 2 number, 3 number, my string, I can have a boolean, I guess I can have an object, I can have another array, and this is all fine in JavaScript. You know, there are many different data types in one array, like numbers, strings, objects, etc. You can do this in JavaScript, but in Solidity, no, it doesn't work like that. In Solidity you have to define what type this array will accept, and since I have written that this is a type of proposal, only an element that is a proposal can be put in this array, and it will be public proposals. I think I wrote it wrong. Yes. So this is the name of my array, this is the type of my array, and here I basically tell Solidity that this is an array. Now okay, we have to remember that we will add an modifier here. So let's start with the function add proposal. Okay, just a moment. Chill. Function adds proposal. So you see, Copilot is suggesting some things again and again. If you are coming from TypeScript, it all checks out. in Solidity, since it's a very statistically typed language, I have to define the types of the parameters also. So in proposal, I want, what do I want? I want the name of the proposal and description of the proposal, because I'm adding a proposal. So again, do you like the music of Eminem is the title, and in the description, I like it like so. There are other rappers and so on, but I just want to know what do you think about the music of this rapper, etc. So remember, name was a type of string, so I have to say type string. For the memory location, I'm writing memory instead of public or private, etc. This means that it will be stored in memory. It won't take a lot of space. It will, I guess it's going to be deleted afterwards. I'm not sure about it. Don't take my word. And title. Hold on. And sorry, I made an error here. It's not name, it's title. Well, we could have used name too, but I want to use title. Sorry about that. And you see, it starts with underscore. You don't have to do it. It's a convention in Solidity. Parameters start with an underscore. And again, I need a string, type of string, memory underscore description. And I want these I want this function to be public, and let's write our proposal. So it's very basic actually. Here we are just going to create a new proposal and push it to the proposals array. How? Let's proposal memory new proposal tag ID. Well, I have to do this normally. I am not entirely sure what was the reason for that. I guess here I had to do a typecasting because I was getting an error. So here I have to let Solidity know that this is an uint of 256. So basically the ID will get the index of the array, the index of the proposal that is in the proposals array. Hold on, I made a mistake here. Title equals to the title that I will be passing as a parameter. As you can see, this starts with an underscore. Description goes the same. Now vote count will be 0 because we haven't voted yet. Bam. Is there a problem? Yes, there's a problem. Bam. You see, when I don't put the semicolon, Solidity compiler doesn't work because I need to put that. Now I need to push this newly created proposal struct to what does it say? Unused local variable, of course, to proposals array, which is very JavaScript like. Bam, that's all gone. Now, as you see, I said I will add a modifier here. I want to, modifiers are like, it's gonna check on a condition. It's like if-else statements, but very useful. It will check whether the strings are empty or not. Let's see, modifier non-empty string memory. Sorry, See, so it's like a function. You see, it's a modifier. It's a special type of function. Let's say named non-empty string. It takes a variable called etc. That's put into memory and is type of string, and require. So this is require. Again, this is a Solidity stuff. So what do I want? I want bytes, array lengths. Yeah, this is basically what I want. I'm going to explain what's going on here. String cannot be empty. And bam. So what is going on here is what did I do? Yeah, semicolon. So this basically says that this is require statement. It's a Solidity syntax that these str variables length should be greater than 0. If it is not, like if it's, which means if it is an empty string, revert the transaction, which means stop, don't do it, take everything back, not everything, but let's say everything back, and give this error message. So string cannot be empty. So do continue the transaction only if this is correct, this is true. If not, give this error message, and this underscore semicolon means continue the execution. And now I want to add this modifier into my add proposal function. After public, you know, yes, oh, after public I will add none. Exactly, I'm going to do that. What did I do? Check. After public I added the modifier non-empty string, which takes title as a parameter and description again as a parameter, two different modifiers. So in the case of one of them is an empty string, I have to close that. In the case that any of them is an empty string, it will give an error. And now I'm going to pause it a little bit. We will continue soon. So see you in the next parts. Okay, now we have our add proposal function. Let's add our other functions. For instance, let's add our vote function. So like users be able to vote, you know. Function vote. It will take a proposal ID, with the type of uint256 and a yes vote in the type of boolean. So uint256 underscore proposal ID and a vote, no, yes vote in the type of boolean. Just a moment. And I want this function to be public so that it can be called outside. And let's start. Now to start with, I want to require that I want to check whether the proposal ID is correct or not. So how will I check it? Basically, I will get the proposal ID from parameter, and yeah, that's what I'm going to do. I'm going to check whether it's smaller than the proposal length, which means whether it is there or not. Like imagine if the proposal length is proposals length, sorry, is 10, so that means there are 10 proposals, and the proposal ID comes as 15. That means, well, it doesn't exist. Why? Because when we are writing the proposals track, when we were creating the new proposal, we were giving the ID of the proposal as the array of the length of the proposals array. So each time when I create a new proposal, it will say I'm creating the 7th proposal struck in the proposals array. The ID will be 7, etc. So this is what it's doing. And what do I need? I want to check before everything whether the user has voted for this proposal or not. I'm going to close GitHub Copilot because this is getting annoying. Yeah. So require. Now this is the mapping part. First I will write it because it gets weird from JavaScript. You know, it gets weird. Now I'm going to explain it, okay? Just a moment. I want to write it first and then I will explain. You have already voted for this proposal. Bam. And now as you can see, I'm starting with an exclamation part, which is a negation. So remember that weird mapping of mapping we have. So has voted for proposal. It takes the proposal ID. Remember, it takes the proposal ID here. It takes this, and it should choose. Should choose the address. Just a moment. How to explain it? Let me think. I talked enough. Now the problem. We are taking the name of the mapping, the nested mapping, and the underscore proposal ID is equal to this ID which we have given in our proposal struct. That's a type of UN256. As you can see here too, it's UN256. We are getting the ID and we are checking this message sender is a built-in Solidity method or function. I'm not sure what's called, but this corresponds to the address of the contract or wallet that calls this function. That's why it's public. So if I call this function, message sender will be the address of my wallet, of my MetaMask wallet or Coinbase wallet or whatever. So this message sender is the address here, and you see that it's mapped to a boolean. Yes, what boolean here? The reason we are using this negation is that this says that if require that in order for this function to continue execution, because the require statement is here after it passed here, first it has to pass this one. After passing this one, it goes to this second require, and it says if continue the execution only and only if the boolean value that we get by looking looking to the address who calls this function regarding to the ID of this particular proposal is false. So this is why this exclamation part is here, this negation is here. Only and only continue to execute the rest of the function if the address who calls this function has not voted for this particular proposal. Okay. Yeah, sorry, it's confusing for me too. Like these mappings are kind of weird for if you are coming from JavaScript. I'm pretty sure in other programming languages there's something similar, but it's a new concept, new understanding of data, etc. Anyway, let's write an if-else statement. If yes vote is true, I'm going to increment the I'm going to explain. Now, what is this? Basically, I'm if yes vote is true, you know, when you write it like this, it's in JavaScript too, it's the same. It means if you don't assign it to something, it means that it checks whether it's true or false, and right now it's checking if it's true. If yes vote is true, let's check the proposals array, which is here, and find the ID of the proposal, because the proposals array is made of proposal structs that has an ID all the time, and I get by querying this ID right now, I get the proposal struct that I want to do something on it, and I want to increment the yes votes by 1 here with this. Now else, if it's false, I guess proposals underscore proposal ID no votes increment. All good. Now, well, whatever the vote was, I still want to increment the vote count. I mean, I'm not really using it, but I mean, why not? Maybe I will decide to use it, you know. I incremented vote count because whether it's yes or no, I mean, it's voted. Now, remember this part was confusing to explain, at least for me, like confusing to go over. Now it will be more clear how it works, because here I will say that this basically what I'm saying here is the contract or wallet who called this function to vote on this particular proposal ID has voted. So now the boolean in here, which corresponds to this address, which is the address who calls the function, is true. So now I can check things, you know. All good. All good. All is good. Now I want to add another function, that is to get proposal votes, and then I will add get proposals too, which will take uint 256 and proposal ID, obviously, because I want to get the votes in that particular proposal. It will be public, so it can be called outside this contract. It will be view, because if I'm not extremely mistaken, view functions, they don't require any gas. Yeah, I'm pretty sure I'm not mistaken, because I'm not changing the state of blockchain. You know, I'm just looking at what's going on there, so I don't have to pay for gas. So that's why it's view function. It should return, you know, I make sure it returns what I want that it should return. Uint 256 yes votes, and uint 256 no votes. So weird compared to JavaScript, isn't it? I'm telling this all the time, but imagine, like, just writing this, we are starting the function. Anyway, now again I want to check the ID of the proposal, whether it's correct or not. We have done it above here, you know, invalid proposal ID if it's smaller than the length of the proposals array. And now I want to return some stuff. Return, what do I want to return? I want to return proposals, proposal ID, yes votes, and let's copy this, no votes. So I want to return that, you know, because I will get the result. And yes, semicolon. What is going on? Tuple component cannot be empty. What's going on? Just give me a minute, I will check, because I don't remember seeing this error. Just a moment. Yes, Solidity compiler versus Murat. See, I made a mistake. Bam. Can't believe. Oh my god. You know, you see what was the error? I put a colon here. Now we can get the proposal votes, and now let's write our last function for this contract, get proposals. It will be empty. Public view returns, well, what will it return? It will return to proposal type array memory, return proposals. And voila. Now I should be able to compile it. Let's see. npx hardhat compile. Let's see if we have any compilation errors. Nope, we don't have any compilation errors. And we are going to do more. Now we have compiled. Next step is to write a deploy script so that we can deploy this contract to a test network. So in the next part we are going to do that. Okay, now I have compiled my contract. It's time to write my deploy script, which is found in the scripts folder. So right now we are in JavaScript territory. I have to first import ethers from require hardhat. Why isn't it working? Okay. Require hardhat. I know it's confusing to require ethers from hardhat, but hardhat contains ethers inside, so we do it like this. We are going to write a function of main. You see now const voting. What was that? Oh my god. No, we are doing our way. Const voting. You see it starts with uppercase voting because the next one will start with lowercase. You will see await ethers. Yes, get contract factory voting. Well, this get contract factory is coming from the ethers library, and since I have given my contract the name of voting, it gets the compiled version of my voting, and yes, const voting with lowercase await voting dot deploy. Now await voting deployed. I want to wait for it to deploy, and yes, I want to give a console log the voting deployed to voting address. I will need this address on my front end, so please save it somewhere, and then I will call this main function. Yes, it's catch error, console error, process exit 1, and bam. Should very basic. This is our deploy script and it should work correctly. Now let's go to our hardhat config, and normally there are other things inside here, like it's like that, but we want to bring this hardhat toolbox. Yeah, and we need the .env package that I have just installed, writing, you see, npm save .env. I'm not sure if it's a development dependency, but who cares at this point. I just wrote it. Just you need the .env package so that you will be able to read from the env file. Other like this env file is where we keep our sensitive data that we don't want anyone to see. So let's write, remember I told you to, let me just copy paste this. Do you remember that I told you to get the quick node HTTP like quick endpoint, see? So I have saved that quick node endpoint that I have saved from quick node, that I have taken from quick node, with the variable name quick node HTTP URL in my env file, and put its value there. Now in order to read it from my env file, I have to write it like process env. Now I will do the same for my private key that should not be shared with anyone, and then module exports, yes, and no, let me, what did I say? I'm going to try something, just a moment. Yeah, let's say 0.9. I think it's okay as long as it's bigger than this particular Solidity compiler. So networks, I will need the network, which we will deploy to goerli. You can use the new one because again goerli is getting closed, and this should be it. You see, like URL is quick node HTTP URL, and my with account the one that's deploying is my private key that is linked, that shows my wallet address. Now I want to, what do I want to? I want to deploy. So oh yeah, okay, we are gonna deploy, and afterwards I think I'm going to deal with tests. I'm not sure if I'm going to deal with tests in this tutorial. I will decide later, but now we are going to deploy. Okay, sorry for the confusion. Now what I want, did I write the, let's see, yeah, it's all good. Just a moment. Okay, npx hardhat run, see, scripts, because our deploy.js file is in scripts folder, and here I tell which network it should be deployed to. Let's cross fingers and press enter. We are waiting. It's again, since it's a test network, it's a little bit slow. We are waiting. Maybe I should pause it a little bit. Oh no! Ta-da! We have our contract deployed. I guess we can even check it. I'm not sure if it's if goerli ether scan. Let's try. Dun, 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 dun. Yes, you see, this is our contract. It's deployed. It's here. Well, we can. I'm not gonna verify it. I'm not gonna do that. But it's here. Like I can see in goerli Etherscan, it has been deployed like approximately a minute ago. It says contract creation from, like this will be my address. This is my transaction hash, and it's block. All is good, you know. We actually right now successfully deployed a freaking smart contract, a voting application to goerli testnet. So congratulations to us. Yeah, let me stop here. I'm thinking of showing some testing. I'm not sure yet. Yeah, I'm gonna show some testing. Okay. In the next section, normally, you know, in test-driven development, we should first write the tests and then the code. But since this is a tutorial, starting with testing would be quite boring. That's why I kept the testing for the last. In the next section, we are going to test our application, whether it works as we like or not. Okay. Hello again. Now we are going to do our testing with hardhat. So again, I go to test log.js. I'm going to delete all of it. You know, again, normally we should have been doing this before deployment, etc. But again, since this is a tutorial, it would be boring to start with testing. So normally we should test. Like testing is like extremely important in blockchain development, because everything is testing. You will lose lots of money if you don't. So okay, everything seems fine. I'm going to change the name to voting.js. Remember our deployment, like we deployed in these. I'm going to copy this because I'm going to do the same here. So let me start getting expect from Chai. Chai is our testing helper, say. So this testing is very, I mean, if you know testing in JavaScript or React, it's basically the same thing. We have to test stuff. Yeah. Now let voting. Now I want to before each test, I want to deploy the contract here so that I can test it. See, voting should work. Is there anything wrong? Let me copy paste from what I have written beforehand. Yeah, I think oh yeah, sorry about the first, because I cannot. You see my mistake here. We create const voting, etc. And here I create votings and then write const again. And I was wondering, oh my god, why aren't these are red? Of course it can't be red, because you declare it again. It's not how it works. So let's start with our first test it describe, no, add proposal function. What the hell? Function. Let's start with testing whether it adds a new proposal or not. So how do we do it? We write it. Yeah, should add a new proposal. Async function. In that function, I'm going to write a title. New proposal. I'm going to write a description, and I'm going to, yes, transaction. This takes represents transaction. Await voting. Yes. So what's going on here? Remember, this voting with lowercase is now deployed voting contract, and as you will remember, in voting I had a function called add proposal. So I'm calling it here with the necessary parameters. It requires a title and description, and I have created my title and description here. So I basically call this function in here, and then const proposal equals, yes, why? Because you know, arrays index start with 0. Now I want to check some things. Yes, I want to expect proposal ID to equal to 0, because remember, in our voting contract, whenever a new proposal was added, the proposal ID was sent to the length. So at first it's 0, it should be go as 0, I guess. Maybe I'm making a mistake here, I don't know. It should check. I expect proposal title to equal title. I want the same for the description. For vote count, expects proposals, not voters, yes votes to equal 0. Yes, you see, like, this is a proposal, but we don't have any votes. We don't have any yes votes, not votes, so they should all be 0, because this is just a proposal and it's not being voted on. So nepix hardhat test, let's see. Yeah, passed, which means it's correct. By the way, I don't remember how I did it. I guess it was in the free code camps tutorial that's you know, Patrick Collins teaches a 32 hours Solidity blockchain course. I did something, and now whenever I write HH, it means MPX hardhat. So maybe time to time I can write HH test. Basically this HH means MPX hardhat in my computer for certain. Let's see, what is this? Nope. Yeah, I don't remember how I did. Okay, let's forget about this. Sorry about mentioning, but if you see this in the wild or in some other tutorials, this you do something. I for the life of me, I don't remember what did I install, most possibly globally, but now apart from tutorials, I never write MPX hardhat because I have a shortcut HH hardhat. So anyway, now I want to check What do I want to check? I want to check that whether it can add multiple proposals. Yes, I want to do that. Let's do that. It should add multiple proposals. Async function. Yes. Const titles. New proposal. Yes. Const descriptions. Yes. Well, in theory, I should be able to add multiple proposals because I didn't put any modifier against it. So this should be okay. I mean, now let's equals 0 e titles length and yeah now const transaction await voting add proposal. Yes, this is exactly what I want to do. And I'm not going to do that. No, sorry, I was just looking at emits. I've written something with emits. I'm not sure if it's necessary here. So let's go with const. Yes, tag. You see, we are just doing the same here, but with the index. See, like instead of titles index, because we are having a for loop, so it should work. See, test will work too. Yeah, passing. So I can add multiple proposals. I'm still at describe, I guess. Yeah. It should revert if title is empty. So you cannot pass empty title, you know, because we added a modifier for that. If you would remember, it should be here, non-empty string, and my add proposal function takes non-empty string modifier here. No. Yeah. Await, expect. No, that's not correct. That is not correct. So the thing is, right now, I'm calling the add proposal function in voting contract, and I'm trying to pass an empty string for title, and it says it should be reverted with string cannot be empty. Let's okay, so that you see mpx hardhat. Okay, it passes, but remember let's try this way. It shouldn't pass. Yes, why? Here it says this error, because it's an error. I cannot pass an empty string. It expects it to be reverted with title is required. But when I go back to my voting contract, I see that this modifier reverts with string cannot be empty. You see, like it expects everything to be correct here. So I cannot give a random thing here. It should show everything that is in the contract. Okay, you know what, let's go to vote function. So I think we tested some things in add proposal. Of course, like in the real world, we cannot do like this. In the real world, it's testing, and with each edge cases and so on, but it's a very basic tutorial. Yeah, so we are going to be a little bit more chill. Yes, we should. Oh my god, it should vote for a proposal. Of course it should. Why not? Now, what do we do? What the hell, man? Basically, we are doing the same thing we have done above. We are creating a new proposal. So far, we know what we have done here. Now we are going to call the here I made a mistake. Yeah. Now in this transaction, I want to call the voting function, which is voting. Oh, what? Voting votes 0 true. What is that? What is going on? Let's go back to our vote function. You see that function vote takes a uint256 of proposal ID and a boolean of yes vote. So what does that mean? Means here I'm passing 0 because I have only one proposal, you know, because I'm calling the proposal only once, so that means I only have one proposal struct in my proposals array, which means its index, so its ID, because here we have given the ID as the index, the length, should be 0. And let's check. So if on that proposal I say it's true, so it's a yes vote, what should happen? Const proposal. Yes, let's get the proposal from proposals array, because here when I vote, it sends like it does something on the proposal so that I can get it from proposals array and see. Well, yeah, these are the same, nothing different here, but here the vote count, remember, it was 0. In these parts it should be 1 because I have voted, and yes vote should be equal to 1 and no vote should be equal to 0 because I voted yes. Let's try. Passed. Now let's do something so that it won't pass. Let's change this to false. Now it shouldn't pass because why not? Yes, it cannot. Well, it cannot pass because if I put false here, I should change yes votes to 0 and no votes to 1. Now it should pass. Yeah. Now something more important. Users should not be able to vote on the same proposal. That's quite important. Maybe the most important thing here. User can't vote twice on the same proposal. Yeah. Dun, dun, dun. Oh, sorry, I apologize. When I was testing the application, I wrote it as describe because, again, it's quite important. So let's do it as a describe statement, I guess it's called, because we are gonna do something with it. User can't vote twice. Yes, let's start with it. Should revert if the user has already voted. Async function. Let's add a proposal with copy paste. I'm gonna copy paste. You see, again, this is the same thing. We are calling the add proposal function. We added a proposal, and now we are going to vote. Let's vote. Await. Voting vote 0. Let's do it through this time. Now, yes, exactly. So here, first I vote true on this particular proposal that with the ID of 0 that I have just deployed, that I just created here. And again, on the second time, I'm trying to vote again on the same proposal with the ID of 0 true. I mean, it doesn't report it. I should be able to write false and it should revert the same. Let's try. I have not tried that. Let's try. Yes, no. Oh. Sorry. It reverted because of. Okay, what's the difference? Ah. You see, you have to write the correct revert statement from here. You have already voted for this proposal and the error caused on because of this on. It should be 4. What's going on here? What's going on here? Again, let's test. Yes, it's passing. Why it's passing? Because I vote true on this proposal with the ID of 0. And then I try to vote again with on the same proposal as false. So I'm trying to give a yes vote and no vote. It doesn't work. I can write true to. It's still gonna pass because I mean I cannot give 2 yes votes or I cannot give 1 yes 1 no vote. Basically, I can only vote once per proposal. Users should be able to vote on a different. Yeah, let's do that. Let's do that. So I have a second screen right there. I don't remember what tests I have written. So I'm checking what should I test here. Otherwise, this tutorial will be hours and hours and hours long, you know. Excuse me. Let's again start with our classic. So we create the proposal and now I'm going to create another proposal, the same thing, but I'm going to change the title. You know, title becomes second title, description becomes second desk, and but this is the same. You know, like await voting at proposal. These at proposals at title and description, and this second title and second description. Just a moment. Okay, it's recording. I just needed to take a very short break. Now, yeah, let's vote. Await voting vote for the 0 true, and it should again. Let's just copy paste from here. I mean, I shouldn't be able to vote again for the same one for the 0. I shouldn't. Let's make it false. It doesn't matter. I mean, I'm just showing it. It can be true or false. It won't affect anything. Now you see the difference here. Okay. Let's make this true again because we are using false here, so that should be const proposal. I'm going to explain. Cool, sorry, it wasn't proposal 1. Wonderful. Now what I am doing, should be able to vote on a different proposal. So I have two proposals here. I'm voting for the first one with the ID of 0, and I'm basically repeating the things that I have done in the previous test. I cannot vote on the same proposal, but I can vote on the second proposal because I have created the second one. Here it has the ID of 1 because it's second. You know, index in array start with 0, 1, etc. Now you see, I'm going to explain. I'm just using GitHub Copilot because, I mean, why shouldn't I? What's going on here? You see, what I'm checking here is I'm checking if when I after I vote for the proposal with the ID of 1, I get that proposal from the proposals array because I know its ID, which is 1. Proposals array, you will remember here, and I'm checking its ID should be equal to 1. Its title should be second title, not the first title. Description should be second des, not description here. Vote count should equal to 1. Yes votes should be equal to 0 because we are voting false, and no votes should equal to 1. Let's test it. All good. Last one. Shall we do it? You know what? Let's do once more. Just a moment. Yeah, let's do just once. One more, which will check whether get proposals function works or not. Yes. You know, we should be able to get oh my god, should return a proposal, you know. So again, I'm creating a proposal. Now I should call the get proposals function from my voting. See, wrong. You are wrong. You are wrong, VS Codes. I need to call get proposals function, which is here. Remember, it should return all of the proposals. And let's see, since I've added 1, see, I'm expecting these. Right now you know how things work, but I think maybe we can do now it's gonna pass, like it should pass. Yes, let's copy paste this part, you know. Let's do some more stuff. Yeah, let's try again. What's going on here? I'm testing. I've created another proposal and I'm testing whether the proposals when I get the proposals array with the ID of 1, if like if the ID is correct, I'm checking if the proposal with the index of 1 has the title, second title. It should, because it's here. Let's check the length. Length should be again, Turkish language snaps back. We should check if the proposal length should be equal to 2 because we have two proposals. Let's try. Voila. If I say 5, it should not pass. Voila, because like you see, it should be 2. Expected 2 to equal 5. It's not gonna work. And that's it. Like, these are the tests I have written for this tutorial. Again, in the real world, testing takes much more time. I hope I was able to help you in some way or another. This is the end of the smart contract part of the tutorial. Next, we are going to create the front end, the UI, for the contract that we have created and tested and deployed, and like everything is perfect right now. We will create a UI and we will test, we will use these functions that we have tested here in our UI so that users can interact with it using their wallets. Anyway, see you on the next tutorial. Ciao.